Today we are going to start section 7.1 and we're going to talk about ratios. We're going to cover some basic definitions and then talk a little bit about simplifying ratios. So to begin with, a ratio is a comparison of two numbers using division that have the same units of measurement. As we proceed on to the next section, we're going to talk about ratios and compare them to rates, and we'll kind of mention that as we're going through these first few examples. A ratio can be written in three different ways. In standard form, it is written with a colon separating two different numerical values. Ratios are read as the ratio of, in that particular case, above 3 to 7. And as a fraction, we can write it as 3 over 7, but it's the same as our ratio of 3 to 7. The first number is our numerator up top, and then our second number is our denominator down at the bottom. Fractions, when we're dealing with these, should always be written in lowest terms. So we do want to reduce our ratios into lowest terms, but we will not be changing them into mixed numbers. So improper fractions are okay. Depending on the different problem that we have, we may or may not need units. Units are not needed for ratios if they have the same units of measurement. If for whatever reason we have something which we're going to classify as a rate that has two different units of measurement, then we are going to want to keep our units of measurement. Okay, so in this first example, we are going to go through and we are going to simplify these different ratios and rates. So the first thing we're going to do is we're going to write these as a fraction. So I'm going to write this ratio as a fraction of 18 miles over 24 miles. All right. Then looking at these, both 18 and 24 are divisible by 6, so we can divide these out by 6. You can choose to cancel common factors, write this out in different ways. Either way we're thinking about it, we're simplifying our fractions. All right. So we're going to divide these both by 6, and then if we look at these, we notice that our units of measurement are the same. So these are actually going to cancel each other out. So what we're going to be left with up top in our numerator, 18 divided by 6 is going to give us 3, 24 divided by 6 is going to give us 4. Again, since these two different values have the same units of measurement, this is something that we call a ratio. Right? So it's a comparison using two numbers using division that have the same units of measurement. If we look at our next example, right? 35 dogs to 15 cats. Both our numerator and denominator are divisible by 5. So we're going to divide both of these by 5. Okay. Notice that here we have different labels, so we're going to keep our labels. Right? We're going to keep these units of measurement. So we are going to take 35 divided by 5, and that's going to give us a ratio of 7 dogs to 15 divided by 5 is going to give us 3 cats. So we have a ratio of 7 dogs to 3 cats. As we go through this chapter, in this textbook, and commonly, if we have different units of measurement, then we refer to these as rates. Then for this last one, we're going to do the same thing. We're still going to simplify our ratio. The only difference is here we have some decimals in our original problem. So we're going to start the same way. We're going to write this as a fraction, 3.6 feet divided by 0.4 seconds. Just like the last example, we have two different measurements in our problem, so two different units of measurement. So this is a rate. We're going to keep our units of measurement after we simplify. As we look at this one again, notice that we have decimals. So what we're going to do is we're going to shift our decimal point. And we're allowed to shift our decimal point as long as we do the same to both our numerator and denominator. So I'm going to shift this decimal point to the right one to give us a whole number. And then I'm going to shift this decimal point also to the right one to give us a whole number. Right? This is equivalent to multiplying both our numerator and denominator by 10. Shifting our decimal point 1 in that direction is equivalent to multiplying it by 10. So then what we have is we have a ratio or rate of 36 feet to 4 seconds. So then we're going to divide out our common factor. So we can divide both of these by 4. 36 divided by 4 is 9. So we have 9 feet left in our numerator. And 4 divided by 4 is 1. So we have 1 second left in our denominator. Again, since we have different units of measurement, we're going to keep these labels as far as feet and seconds go. Again, we're allowed to shift our decimal point as long as we shift our decimal point the same number of places in each problem. So if we shift it once up top in our numerator, we have to shift it once in the bottom. If we were to shift it twice up top, then we would have to shift it twice in the bottom down in our numerator as well. All right. So as we're going through these simplifying ratios, when we think about simplifying ratios, what that should tell us to do is that we want to write these fractions, and we want to write these fractions in simplest form.